Hi everybody, good night. Without long introduction, I would like to start today's chapter relative velocity. Relative velocity. So, I will take simple definition of relative velocity. What is relative velocity? How it can be found? What is its direction? What is change in velocity? These things are to be discussed today. So, relative velocity, you can write if possible, relative velocity. This is the topic, relative velocity. If two bodies changes their positions or distance either in magnitude or direction or both, then the body is said to have relative velocity. To each other. This is simple definition of relative velocity. If two bodies changes their distance either in magnitude or direction or both, then the body is said to have relative velocity to each other. Suppose one body is going towards east. Suppose the name of the body is P and its velocity is denoted by Vp, and another body again going and its name is Q and name of the velocity is Vq. Then we define velocity of more clearly relative velocity of P with respect to Q is given by Vp minus Vq. That is, we take the opposite direction of second vector and we subtract from the first vector, that is Vp minus Vq. This will be known as relative velocity of P with respect to Q. So, relative velocity of P with respect to Q is given by Vp minus Vq. In the similar manner, relative velocity of Q with respect to P is given by Vq minus Vp. That is, in order to find relative velocity of P, we just take the opposite side of second vector Q and then add, that is Vp plus minus Vq. In the similar pattern, Vq plus minus Vp, that is we take opposite direction. Suppose Vp is here, Vp in this direction, and then Vq will be just opposite to this direction, and it will be written as Vq, opposite to direction Q. Clearly, it will be subtracted from the velocity of P to the velocity of Q, and so on. Now, change in velocity. Change in velocity of a body. Change in velocity of a body is given by del V is equal to V2 minus V1. V2 minus V1. Where V1 is initial velocity. V1 is initial velocity and V2 is final velocity. V2 is final velocity. So, as a measurement of change in velocity, we take final velocity minus initial velocity, and its magnitude is given by del V is equal to under root V1 square plus V2 square, very important formula, plus twice V1 V2 cos theta, twice V1 V2 cos theta. Now we wish to take a numerical problem from this. A man can swim in still water at 6 km per hour. Here is the question. A man can swim at 6 km per hour in still water. A man can swim at 6 km per hour in still water. He wants to reach just opposite his. He wants to reach just opposite to it. Just opposite to it. His starting point, just opposite to his starting. In which direction he should swim? Question is, in which direction he should swim? In which direction he should swim? This is first question. In which directions he should swim? Also find the time. taken to also find the time taken to reach opposite sides. Opposite if the width of river is √3 kilometer. Now we will get understand you by a diagram. Suppose the flow of the river is as follow in diagram. Arrow shows the direction of flow. Arrow shows the direction of flow. Suppose a person is standing at the point M in one side of the river and he want to just reach the just opposite side at the point N. Let us consider that he is swimming at 6 km/h as given and flow is 3 km/h, making an angle theta, that is which is direction, making an angle theta so that he can reach just opposite side because this flow of current will pushes him to go at right angle and reach just opposite side. Then we have from figure M and P, let us suppose this point is P, then sin theta is given by P by H, that means 6 by 3 by 6 is equal to half. Sin theta half value is given by sin 30 degree. Therefore theta is equal to 30 degree. This is direction. This will give you direction. Now we wish to find out the resultant velocity. So resultant velocity, as it is a right angle triangle, so resultant velocity is will be under root 6 square minus 3 square, which will give you 3 root 3 km/h. Now for the first, the width of the river is given that √3 km. Therefore time taken can be found T is equal to distance to be traveled divided by speed. Here distance is √3 and speed is 3 √3 km. kilometer, and this is kilometer per hour. Kilometer will be cancelled and this will be happening 1 by 3 r, which will give you 20 minutes, and this is the final result. Time taken by to cross the river is 20 minutes, and direction is theta is equal to 30 degree. Thank you for watching. I hope that this video will be helpful for you. Like it, share it. I will meet you with a new video next day. Till then, take care and bye.